Earth Systems 3209. Unit 4, The Forces Within Earth. References for Unit 4 can be found in the textbook in Chapters 4, 15, 16, and 19, and also in Appendix A and Appendix B of the Curriculum Guide. Unit 4, Topic 2.3 will look at the Plate Tectonic Theory and the development of the Plate Tectonic Theory. We will focus on describing the theory of plate tectonics. When we look at the Plate Tectonic Theory, this theory of plate tectonics is one of the greatest advances in the 20th century. In the 1960s, a scientist named Alfred Wegener proposed the continental drift theory, and Turo Wilson put forth the idea that the Earth consists of several different fragments called plates, instead of being made up of one static, rigid, solid outer layer of Earth. These ideas revolutionized the way scientists think of the Earth today. Information on this topic can be seen in your textbook on pages 525 to 527. When looking at the plate tectonic theory, the outer Earth is divided, according to Wilson, into major tectonic plates. A tectonic plate is a massive, irregularly shaped slab of solid rock, generally composed of both continental and oceanic lithosphere. Plate sizes vary from a few hundred to thousands of kilometers across, with the Pacific and the Antarctic being two of the largest. These massive slabs of crust seem to float because of their composition. Continental crust is composed of a granitic rock, which are made up of felsic minerals, and these minerals are less dense. Therefore, it makes continental plates have a lower density than the rest of the rocks that make up the lithosphere. Oceanic crust is composed of basaltic rocks, which are made up of mafic minerals, and these minerals are more dense. Therefore, your ocean crust would have a higher density than the other rocks in the lithosphere. Your continental crust can range up to 100 kilometers thick underneath mountains, and your oceanic crust is generally 5 to 7 kilometers thick and mainly found beneath the ocean floor, beneath the ocean level. When looking at plate tectonics, it was noted that by the end of the 1960s, the ideas of continental drift and seafloor spreading were united, and they gave rise to a new theory that better explained the idea of a mobile Earth. This theory was called the Plate Tectonic Theory. The birth of the Plate Tectonic Theory helped explain various geologic phenomena. Scientists believe that the grinding movements of Earth's lithosphere generate earthquakes, they create volcanoes, and they deform large masses of rock, which build up to form mountains. Let's take a closer look at the Plate Tectonic Theory. The Plate Tectonic Theory was put forth by a Canadian geologist named Turo Wilson. He put forth the idea that tectonic plates exist all over Earth's surface, and they're basically bordered by what's called tectonic boundaries. The theory of plate tectonics states Earth's lithosphere is divided into 7 major tectonic plates, and these tectonic plates are named the North American Plate, South American Plate, the Pacific Plate, the African Plate, the Eurasian Plate, Australian Plate, and the Antarctic Plate. So the entire surface of the Earth is broken into 7 major tectonic areas called the tectonic plates. These tectonic plates are in continuous slow motion relative to each other, and the motion occurs along one of 3 different boundaries that are found bordering each tectonic plate. So in conclusion, Wilson's theory of plate tectonics says the Earth's lithosphere is divided into 7 major plates, and at the edge of each of the plates you will find one of 3 different types of plate boundaries. Let's look at the different types of plate boundaries that can exist at the borders of each tectonic plate. The first boundary is called a divergent boundary. At divergent boundaries, plates tend to move apart, resulting in the upwelling of molten material from the mantle, and this will tend to create new ocean floor. Features on the ocean floor where this occurs are called ridges, and ridges show this form of plate movement, where the plates tend to move away from one another. The forces associated with divergent boundaries are called tensional forces, and they cause the plates to move apart. So if we look at the diagram below, we notice that magma rises from deep within the mantle. As it rises up, convection currents tend to take the plates in opposite directions. So at the ridge that we see here, magma will rise up and it will cause tectonic plates to move off in different directions. As the tectonic plates move away in different directions, new seafloor is created along the ridge, and the plates move off in different directions, opposite directions. This is what Hess called seafloor spreading. A second type of boundary found at the edge of tectonic plates is one called a convergent boundary. Convergent boundaries show plates moving together. This causes one slab of lithospheric plate to be consumed into the mantle as it descends beneath another tectonic plate called the overriding plate. Some features that form at this boundary would be known as a trench. And trenches are formed when lithospheric plates subduct beneath another lithospheric plate, and it causes a depression. At these boundaries, the lithosphere is generally destroyed. Forces associated with convergent boundaries are called compressional forces, which cause the plates to move together. So if we look at the diagram to the right, we see that we have one tectonic plate that collides with another tectonic plate, and both these tectonic plates are moving in opposite directions. As they collide, one of the tectonic plates, generally the more dense of the two, will move down into the mantle beneath the other, which is called the overriding plate. As a result, the subducting tectonic plate could melt. As it melts, it produces magma, as we see here, and this magma will rise upward until it extrudes the Earth's surface, producing volcanoes, if in mountains, but in this case, on the ocean floor, it'll form volcanic islands, which is called a volcanic island arc. So in conclusion, convergent boundaries occur where we have two tectonic plates colliding with one another, where one tectonic plate is subducted beneath the other, where it's destroyed, and we generally get some sort of volcanism occurring at these tectonic plates. The third tectonic plate is a boundary called a transform boundary. When we look at the third example of boundaries that exist along the edges of tectonic plates, namely this one, a transform boundary, these plates move past each other in opposite directions. The lithosphere is not created or destroyed at these boundaries. We tend not to see any vertical movement of the tectonic plates, the lithosphere. An example where this is evident on the Earth's surface in North America would be in California, along the San Andreas Fault. The forces associated with transform boundaries are called shearing forces, and these cause the plates to slide past one another. So if we look at the diagram below, and here we look at a bird's eye view, in other words, if we were in the air looking down on the surface of the Earth, we would see that a transform boundary exist where two tectonic plates slide past one another. In this diagram, we see an indicator, such as a road, a river, or something of the sort, that is actually separated because of the motion of the tectonic plates. The plate that's above the actual fault line will be moving to the left, and the plate that's below the fault line will be moving to the right. These arrows shown in the diagram should be in the opposite direction. This plate will be moving to the left, and this plate will be moving to the right. Therefore, it would displace a road, a river, or some topographical feature on the Earth's surface. So, at this boundary, we don't see any crustal material being formed, being created, as you do at ridges, and we don't see any crustal material being destroyed, as you do at trenches. We just see two tectonic plates sliding past one another. So they move in opposite directions. Some evidence to explain the plate tectonic theory focuses on 5 main topics. Number 1, earthquake evidence and volcanic evidence. Number 2, we see polar wandering. Number 3, magnetic reversals and seafloor spreading. Number 4, ocean drilling and heat flow. And number 5, hot spots located within tectonic plates. These 5 pieces of evidence are 5 pieces of evidence that support the plate tectonic theory, and they will be discussed in a further presentation. Let's look at example number 1. First question reads, which Canadian scientist is recognized for his contribution to plate tectonic theory? So when we look at the choices down below, we see Harry Hess, which proposed the idea of seafloor spreading. Drummond Matthews, which proposed ideas behind magnetic reversals on the seafloor. Dan McKenzie, which proposed ideas behind plate tectonics. But the best answer here will be answer D. Turo Wilson was a Canadian geologist who formed the basis and provided the framework to propose the theory of plate tectonics. Second question reads, what is the major driving force of plate tectonics? The driving force behind plate tectonics is focused in the upper mantle, where we see the upper mantle as a mobile layer where we see convection currents, which are responsible for carrying the tectonic plates that lie or sit directly on the upper mantle. So the answer to this question will be D. What is the major driving force of plate tectonics? It would be the upper mantle convection. Example number 2. First question reads, what happens at transform plate boundaries? At transform plate boundaries, we see 2 plates sliding past one another where neither is created or destroyed. So if we look at our answers, we see that D will be the best choice. Tectonic plates move past each other along a fault, which is called a transform fault. So what happens at a transform plate boundary? The answer would be D. Plates move past each other along a fault. Second question reads, which plate boundary is demonstrated in the diagram to the right? So if we look at the diagram to the right and take note of the arrows moving in opposite directions, which indicate tensional forces caused by convection currents in the mantle pulling plates apart. This would be an example of a divergent boundary, where 2 tectonic plates move away from one another in opposite directions, creating a mid-oceanic ridge. So the answer to this question will be divergent boundary, which is seen to the diagram to the right. Your turn. Take the time to prepare an answer for the following question, and the solution will follow on the following slide. You can pause your recording now to prepare your answer. The question reads, according to the Plate Tectonic Theory, Earth is divided into how many major tectonic plates? So when we look at the Plate Tectonic Theory proposed by Turo Wilson, we know that Earth's surface is divided into sections of lithospheric plates called tectonic plates. There are 7 main tectonic plates, which are divided into many smaller tectonic plates. The main tectonic plates include North American Plate, South American Plate, the Pacific Plate, the African Plate, the Eurasian Plate, Australian Plate, and the Antarctic Plate. So these are the 7 major tectonic plates that the Earth is divided into. Each of these plates can then be further subdivided into minor plates. When we look at an overview of the points covered, first point suggests that Turo Wilson was a major contributor to the Plate Tectonic Theory. He laid the framework by which the Plate Tectonic Theory was proposed. Wilson, in his work, he stated that the Earth is divided into 7 major tectonic plates, which are continuously slowly moving relative to one another. This motion occurs along one of 3 different types of boundaries which border each plate. The 3 different types of boundaries that are located at the edge of each tectonic plate include divergent boundaries, where tectonic plates move apart, caused by tension forces; convergent boundaries, where tectonic plates move toward one another, caused by compression forces; and transform boundary, where tectonic plates slide past one another, and this is caused by shear forces. So, in summary, Turo Wilson was the main person who contributed to the Plate Tectonic Theory by stating that the Earth's surface is divided into 7 major plates with one of 3 different boundaries, divergent, convergent, and transform boundaries, bordering each of the individual tectonic plates.